having the competitive edge. That is often referring to having a better engine, having better batteries, or fresher tires, or whatever it could be. But an overlooked thing in especially the 1/28th scale, it's not as much, it's a big topic in 1/12 scale and 1/10th, of course, in competitive racing. It's the balance of the chassis. And with the balance of the chassis, there's a lot of weight going into the electronics. So today we are gonna go through how you put in electronics correctly. And yeah, let's see where it goes. As all of my other videos, just one big take and we'll take it from there. One of the comments I had, how do you curl the engine wire, the receiver wire or the servo wire like this? It's really simple. It's a nice way if you don't want to shorten your cable to actually have some cable management. It's just this is a 2mm hex driver, and you actually just curl the wires up around it. I've clearly done this before with this one, but you actually just curl it up like this and tighten it down, and you're left with very nice wires. So that was that out the way. So the setup of the electronics. So I have been blessed with a lot of years in 1/12 scale, and normally when you put in electronics, you have these. Not a lot of people have these, but I'll talk you through how this is done, and you can replicate this because it would be fairly simple, fairly similar on other chassis. On the bottom of the chassis, there are these small holes. If you notice them, they're here as well, right there. And it's for it's for referencing the plane when you mill it out, but it's used afterwards as, I'll just find the holes here, as a tool for balancing the weight out, like the electronic layout. So that is what I've done over here, and I'll explain it. The idea behind it, all of these have been put in using this exact setup. You don't connect tires, but you have the fully assembled car, not the rear part, and you put in the electronics and make sure that it's stable. This will show if there's any imbalance in the chassis or the layout that you've just done. So with that out the way, some of the ideas behind this. So first of all, when you have the brass chassis like this, you don't have the mounting holes for example, the ESC, or if you're running an aftermarket ESC. So what should you use? You should use foam tape. I've seen this clear nano tape. It doesn't have a lot of give. This is, as the word implies, foam. So it has a lot of small holes that can pick up the vibrations, for example, and it doesn't affect the flex of the chassis. How much does a chassis flex? Well, it's quite a bit. Not the brass one per se, but the carbon fiber is very pliable. Carbon fiber is relatively soft. So I use the foam tape, for example, for this ESC, to not affect the flex. I know it sounds a little nitpicky, but that's just always how I've done it. The servo install for these, it has this bracket. You can get it in aluminium as well. Doesn't matter. At least I don't think so. So the more important thing than this being an upgraded aluminium part of this is that the servo needs to be free float. So what does that mean? This is just a gauge, checking gauge. But you need to have air underneath the servo for the same reason that you need foam tape under the ESC to not affect the flex or the tweak of the car, it's called. How is this done? If you've never done it before, I do it by eye measure because I've installed it in almost 1,000 cars, I think. you would have this whole assembly out, the servo mount and the servo. You cut 2 pieces of normal printing paper and you put underneath the servo. So printer paper here, servo on top, just cut to exact size of the servo, not going above the edges. Then you take the mount, install it, and you push down on the mount, like the mount here, and you screw in the servo. In that way, when you lift it up and remove the paper, you will have this 0.4 or 0.45 millimeter air gap underneath, and your servo will be free floating, and you just install it. Okay. So the servo has a lot of overhang on this side. Of course, to accommodate, there needs to be some kind of room made in this car because it's super tight. So the servo is a lot on this side. So you need to have a lot of the weight on this side. For example, I put the wires here. The connecting part of the receiver is also on this part, for accommodating that extra layout of weight, that extra overhang of weight over here. Everything else just needs to be like in the center. It's of course done easier by the balancing thing. You can just put everything on and see, okay, is it somewhat balanced. For the battery as well, to balance out that it has a huge wire here and has a lot of weight overhanging here, this had this I found another battery here, this overhang here in the battery in the back. So I just very gently snipped that off just to have the battery go as far as it could over here. Wasn't enough, so I took out a lot of this just to move the battery longer over in this direction. So over here, and here you can actually see the battery from the side, and over here you have to look in to see it. So it's moved quite a long way this way to accommodate for both the locking mechanism here and also the wires. And the way I lock in the wires, so it does, I've seen people just do like this, plug them in, but the battery wires will often interfere with the movement of the rear part. So I just ground out a little on the inside here, so I can do like this and plug it in. And there you go. So this can move freely without touching anything. And going back here to the engine, the wires are also purposely a little bit longer going on to onto this, and it's because of the rear part balance. So never heard of rear part balance? It's also a quite overlooked subject. The rear part balance is explained best and checked this way. Right now this is of course done correctly, so we'll just put some weight in here. And what this does is, I'll just try to get some focus back here. Okay, so it's when you lift up, not having anything connected. I'm sorry, it's binding up a little bit here because I just rebuilt this. And you can see that the part is unbalanced by having it on the ground and lifting it up, and it will go to one side like this. And how can you actually do something about that? Well, you can do it in 2 steps. I'll usually do it in both of them. You can space the engine out. If it falls this way, you'll need to have some weight in that direction. So the motor should be moved this way. I've done that by 0.2 millimeter shims on the other side where the screws goes, and that pushes the motor this way. It wasn't enough, and I wasn't happy with the amount of threads I had left in the screws to hold the actual engine in. So I needed to do something else. So I just made the wires here a little bit too long so that the wires carried some weight out onto this part back here. And how you actually check this is just resting your car on the edge and lifting it up. Not connecting the side springs or anything, and you're just lifting it up. And it shouldn't fall to either side. Okay. So that is how that is done. And I think that was it for balancing out the electronics of the car. And see you in the next one.